Okay, so now we are going to talk about acceleration, and acceleration is basically the change in speed. So we are going to define acceleration as the rate of change in velocity. So suppose that you're driving at 20 miles per hour, right? And then you hit the acceleration, the pedal in your car, and your speed goes to 25 miles per hour, right? And let's suppose that that happens in a few minutes. So let's say it happens in 0.1 hours, right? So what is your acceleration? Well, your acceleration is going to be defined as the change in velocity, delta V, right? Acceleration is going to be defined as the change in velocity, which is equal to, and I need more space, so let's move over here. A is equal to delta V divided by delta T, and this is equal to final velocity minus initial velocity. That is the change in velocity divided by delta T. So that is your definition of acceleration, is that definition there. So let's do the calculation here. We have 25 miles per hour minus 20 miles per hour, and then you divide that by 0.1 hours. So this is equal to 5 miles per hour divided by 0.1. This is equal to 50 miles per hour every hour. So that means that your acceleration during this short time, which is 6 minutes, so it took you 6 minutes to go from 20 to 25 miles per hour, is 50 miles per hour every hour. So if you continue driving for an hour, your speed would have increased by 50 miles per hour. So after 1 hour, you'll be driving at 20 plus 50 would be driving at 70 miles per hour. So that is the definition of acceleration. So units for accelerations are meters, are basically, let's say your velocity, you're measuring in meters per second, right? Meters per second. So the units of accelerations would be meters per second every second, or meters per second squared. So that basically is the way we write out the units for accelerations. If you're writing in miles per hour, so it will be miles per hours every hour, or miles per hour squared. So that is the units of acceleration. So for instance, let's calculate the acceleration of a Corvette. So it goes from 0 to 27 miles per hour in 3.6 seconds. So delta V is 27 minus 0 is just 27. So this is delta V here. This is delta V. And then delta T is just 3.6 seconds. So this is delta T. So delta V over delta T gives you 7.5 meters per second every second. So this is telling you that a Corvette every second increases the speed by 7.5 meters per second. Compare that to a Chevy, right? So a Corvette takes 3.6 seconds to go from 0 to 7.5 meters per second. A Chevy would take 9 seconds to go from 0 to 7.5 meters per second. As an exercise, you should calculate stop the video right now, pause it, and calculate the acceleration for the Chevy and see what value you get. Okay, let's do a simple example here, animal acceleration. So like most predators, so lions can go really fast. They can sustain really fast accelerations. In particular, they can go up to 9.5 meters per second squared. So for about 1 second. So that's the acceleration they can sustain for that long. So how much time does it take for a lion to go from rest to a typical recreational runner speed of 10 miles per hour? So first we need to change this 10 miles every hour, 10 miles per hour. We need to change that to meters per second. To change that, we are going to multiply by 1, right? And 1 is what? 1 is, we want to get rid of the miles, so we want 1 mile downstairs. And upstairs we want meters, so we want 1609 meters because there are 1609 meters in 1 mile. And to get rid of the hours, we want to multiply by 1 again. So upstairs now we want 1 hour. Downstairs we want 3,600 seconds. This is 1. This is 1. Now I can cancel stuff. Miles and miles cancel. Hours and hours cancel. The seconds stay. And then I can do this math. And if I do this math, I find that this is 4.5 meters per second. So now I want to calculate the time that it takes for the lion to go from 0 to this 4.5 meters per second speed. So remember the definition of acceleration. Acceleration is equal to delta v over delta t. I want to calculate time, so I have to move the time to the other side. So I'm going to multiply by delta t. Delta ta is equal to delta t delta v over delta t. So I'm multiplying both sides by the same thing, so nothing happens. So I can now, so I have delta t here. So I can cancel these two, and then I get that delta ta is equal to delta v. So now I'm going to divide by acceleration. So I get delta ta divided by acceleration is equal to delta v over acceleration. So now I cancel these two accelerations, and I end up with delta t. Delta t is equal to delta v over acceleration. So now I can plug in the numbers. So delta v is 4.5 meters per second minus 0, right? Because to start from 0, divided by the acceleration, which is 9.5 meters per second square. And then I can do the math here, and I get that this is 0.47 seconds. So that is the time that it takes for a lion to reach the speed of a recreational runner, which is 4.5 meters per second. Thank you.